In this video, we're going to learn what a reference angle is and why it might be useful. If we are looking at reference angles, let's start with the 120-degree angle. The first thing I want to do is be able to draw a 120-degree angle. If we look at our axis, 0 degrees is on the right side, 180 degrees is on the left side, and we know that 90 degrees is straight up. So 120 degrees would be about right there, and that would be our angle. If we're looking at a reference angle is the angle made between the x-axis and where our angle stops. So this angle in blue would be our reference angle. And we'd want to determine how big that is. So this is a 60-degree angle because it's 60 degrees short of 180 degrees. So I could say my reference angle is 60 degrees. Now I could do the same thing with one that goes past 360 degrees. So if I draw this angle, I know that one time around is 360, and then I would need an additional 35 degrees to get to the ending point on that angle. So my reference angle, I'd want to go from the x-axis to where my angle ended, and we said that that was 35 degrees past the x-axis. So my reference angle, I could say, is 35 degrees. So each one of these we saw was the angle between the x-axis and where the original angle ended. And that's what we call our reference angle. So let's try some more. A 710-degree angle. Now 710 is just shy of 2 full revolutions. So if I go around once, that's 360, go around almost twice, that would be 710 degrees. But I know that 720 degrees is 2 full revolutions. So if I look at the difference between those, this angle that's left over is just 10 degrees. So my reference angle is 10 degrees. Now, that may look like a negative 10-degree angle because we're going down, but when we're talking about reference angles are always positive angles, regardless of their location or the direction that they went. We refer to a reference angle as a positive angle. Now, if we look at the one on the right here, it's in what we call radian measurement. So what might be helpful here is to convert this back to degrees. So if I take my angle and multiply it by the conversion factor of 180 degrees divided by pi radians, I can see that the pi's would cancel out. I can also see that 6 will go into 180 and leave us 30. And then if I multiply the 30 and the 5, I get a 150-degree angle. So if I want to find the reference for that, let's go ahead and draw the 150-degree angle, which would end about right there in the positive direction. But the actual reference angle is what would be left over. So if this was 150, what's left over to get to 180 would be 30. So my reference angle would be 30 degrees. So each time we found this reference, we draw the angle and then find what's the distance between the end of the angle and the closest x-axis. We don't want to go back to the y-axis, we always go back to the x-axis. All right, let's try 2 more. This one here is a negative 100 degrees. So negative angles go in the opposite direction as positive angles. So a negative 100 degrees would end up about right there, just past 90 degrees in the negative direction. So if I want to find the reference angle, I come over here to the closest x-axis, and since the right side of that angle between the y-axis and the end of the angle is 10 degrees, I know that this left over is 80 degrees. So my reference angle would be 80 degrees. And again, we call that a positive angle because it's a reference angle. And the last one here, a negative 4 pi over 5. Again, it might be helpful to convert it to degrees, or we could keep it in radians, and we can talk about that another time, how to do that. But for today's purposes, we'll convert this. So if I take 180 and divide it by pi, which is our conversion factor, the pi's are going to cancel out. And then I can take the -4, multiply it by 180 degrees, and divide it by 5. And I end up getting a negative 144 degree angle. So negative 144. So if I draw that out, negative 144 is going to end up down here in this lower left corner. And I go in the negative direction to get there. Now if I take a negative 144 degree angle and see how far away it is from 180, I find that this left side of the angle, what's left over to the x-axis, is 36 degrees. So my reference angle on this would be 36 degrees. And if you wanted to write that as a radian measurement, we could write that as pi fifths. Either one of those would be fine. The degrees probably makes more sense to a lot of students, so you're perfectly fine to keep it there. But if we wanted to match the original problem, we could write it as pi over 5.